Good morning, Geometry. Mr. Flory here. This is 11.3, the Cayenne Tower, I think it's pronounced. The building on the left side of the picture is called the Cayenne Tower. It's in the city of Dubai. The tower is about 306 meters tall. It's made up of identical floors that are each rotated slightly compared to the one underneath it. So here's the floor plan. Each floor is the same chevron shape that is approximately two parallelograms put together, with the dimensions shown in the image. The circle in the floor plan shows the cross-section of the core, which is used to circulate air and carry pipes and wiring throughout the building. The area of the Cayenne Tower, the area of the Cayenne Tower's base is 57 times 35, or 1,995 square meters. Why is it possible to find the area of the chevron, the shape, by just multiplying the width and the height? Because this isn't a actual rectangle, how come I can just do base times height if it's a different shape? And the answer is, I guess it's like the symmetry of it. If I were to kind of draw a straight line down from the top left vertex to the bottom right vertex, and took this triangle right here, cut it out, and put it right here, it would fit perfectly in here, and this shape right here would be a rectangle. And if I can find the area of the rectangle, it would be the same as finding the area of the chevron. And the base is 35, and the height is 57. So I can just do 35 times 57 and get that answer. So why is it possible to find the area of the chevron shape by multiplying the base and the height? I guess exactly what I did. You can cut a triangle out from the top left vertex to the bottom right. Excuse me, bottom left. Move it to the other side. Move to the side of the chevron, and it'll make a rectangle. '57, not 52. Anyways, describe how the total volume of the building can be calculated. Well, that's going to be easy. Once we know the area of the base, they told us that the height was 306. So take the area of the base, and they told us it's 1995. Multiply it by the height. They're not asking us to calculate it, but it would just be the area of the base, 1995, times the height, which is 306. And you could toss on the calculator. I'm getting 610,470. What are we in meters? Yep, cubic meters. Actually, no, I want to use this guy. That's nice, right? What's the shape of the core of the building whose cross-section is a circle? So remember, these are just a bunch of, this is like what one floor looks like. If we stack a bunch of these up and start twisting it, it's going to give us this shape right here. But one thing that's going to be the same is the circular cross-section is always going to be in the middle, and we keep stacking these all the way through the middle. And if we keep stacking them, we're just going to get that shape all the way through. So we'll still have that chevron shape that's getting kind of spun. But as we keep going through the building, this circular tube area is going to just make a cylinder. So a cylinder. Right, so you have that cross section is a circle, and it keeps going up. And even if you rotate it, it's still gonna, a rotation is not gonna throw this off center at all. It's gonna just stay a cylinder all the way. How do you find the volume of the building's core? So this is the core, that circular cylinder area, or excuse me, volume, including describing the measurements that would be used. So we'd find the area of the base and multiply by the height. The base is a circle, and the radius is what? What's the radius? So if the whole diameter of the circle is 17, then the radius is half of 17. So the radius is half of 17, which is 8.5. So we'd find the area of the base, which is a circle with radius 8.5, and then multiply it by the height, which we said was 306. Yep, 306. So let's just actually find that volume because we're going to need it for the next question anyways. So the volume of the core or the cylinder is going to be the area of the base, which is pi r squared, times the height, and the radius is 8.5, and the height is 306. So put that in the calculator, and I'm getting about 69,455.9. All right. So what percentage of the building's volume is taken up by the core? How much of the building is taken up by its core? I mean, just looking at it, it doesn't look like it's, it's definitely less than half. It looks like a small percentage. So if I want the percentage, I need to take the volume of the core, and what percentage of that is the volume of the total? If I just divide the volume of the core by the volume of the total, that'll give me what percent of it is covered by the core. So the core we know is 69,455.9. And we know that the volume of the whole thing is 610,470. And so if we divide those, we're going to get approximately 0.11377, which is really, it's about 11.4%, right? That's 7, we'll round that up to a 4, and we'll call that 11.4%. Anyways, that's it.